2 minutes.
All right, I'm standing by.
Yeah.
دخلت خلاص. شكرا.
السلام عليكم.
وعليكم السلام ورحمة الله وبركاته.
Good morning, everyone. I would like to thank you all for attending this series of talks organized by ETC. It's really nice to see new faces joining us today, as well as our colleagues and participants who joined our previous sessions. Welcome, everyone. Few reminders before we begin. The session is recorded, and you may raise hand for questions at the end of the session. Our guest speaker for today is the General Manager for the Network Systems Development United Company, NSDU, and an Information Technology Senior Consultant System Engineer with 20 years of experience and proven success developing and maintaining excellent information systems for government, education, hospitality sectors, healthcare, and industry. He holds a bachelor's degree in science in ICT with an outstanding interpersonal and team working skills that complement a wide technical foundation and knowledge of IT technologies and methodologies across every aspect of system and network design, implementation, and management. Besides that, he designed and implemented network solutions in Oman for many organizations, such as Sultan Qaboos University, ORPIC, Omantel, Ooredoo, Royal Air Force, and many others. Without so much further ado, may I call on Mr. Yusuf Al-Maleh. Mr. Yusuf?
Very good morning, ladies and gentlemen. Thank you, Ms. Mahfouza, for the introduction, and it will be a great honor to me to speak on this session on the stand of University of Technology and Applied Sciences, and big thanks to the organizers in Higher College of Technology. Today I'll be speaking about wireless networking. I would like to share my slides. If you can allow me to share my slides, Ms. Mahfouza.
Yes, Mr. Yusuf. You may share your slides.
Yes, I've already done that. Thank you so much. I hope you all can see my presentation very well. And if you can't see it, please type a comment or raise your hand. All right.
Yes, we can see it, Mr. Yusuf.
Very well, very well. So as I said, today I'll be talking about wireless networks. I'll go through, my agenda includes 7 points today. So I'll speak briefly about computer networks, then I will jump to wireless standards, and I'll talk a little bit about wireless frequencies, wireless antennas, wireless modes, and wireless securities, and I'll speak a little bit about wireless planning, how to plan a wireless network. Then we can go to a Q&A session. Computer networks. All right, a computer network, as we all know, it's a group of computers that potentially has potentiality to transmit and receive data, voice, and video traffic between devices. And the wireless, the network can be wired or wireless, or even in the wired can be fiber or copper, and in the wireless could be on multiple frequencies, that 2.4, 5 gigahertz, and 6 gigahertz, as we will see in the further slides. So a network consists of three main elements: a network device, which represents the switch, the router, or the wireless access point, and the medium that we transfer our data through it, which could be, as I said, it's a UTP cable, a fiber optic cable, or a radio spectrum. And then we have the network client, which will be a client server, of course, which will be the PC, the servers, the mobile, the IoT. The idea behind that is to share. The server will be having information and will be shared, and the clients will be connected to this server to take from this information, like a web server, like a brand server, and like IP telephony server. So a network is a fundamental in sharing network, and it's a key to save cost and enable productivity for all employees, students, and individuals. In the early days, networks were totally independent. Each network vendor was totally independent from the other. Like before 1984, networks were like, for example, IBM networks were only talking to IBM networks. IBM network, it consists of all IBM devices and cannot speak to other vendors like 3Com or Lucent or one of the early vendors. So each vendor has his own standards, and his own network, and did not talk to any other network. So it was difficult for companies to implement network, where if you want to go for a network, you need to go for a single vendor in the early days. That was until 1984, and where the open system interconnection, the OSI model, was developed by the ISO, International Organization of Standardization. They developed this OSI module to make the guidelines and the specifications of all the networks. So each network vendor should follow this module, which consists of 7 layers. And they divided this into 7 layers, and they defined the function of each layer. I'll start for layer 1, which is the physical layer. It represents the medium, the media, whether it's a cable, whether it's a wireless. Then the layer 2, it represents the MAC address. And here you hear sometime like layer 2 switch. A layer 2 switch can only understand up to layer 2, cannot understand the layers above. So when you hear about layer 2 switch, that means this switch can only understand MAC addresses. Then layer 3, it represents the IP address, and we can find layer 3 devices in routers and layer 3 switches and some of the modems. Layer 4, it is for the ports, and I can, if I want to represent or to explain ports here, it's like gates. Each protocol has represents an application. For example, the TCP ports, port 80, for example, represents the HTTP traffic. Port 443 represents the HTTPS traffic, and so on. And the layer 7 represents the readiness of the host communication. Like the two hosts are ready for establishing the connection between the two hosts. And the presentation represents the encryption of data, and application, it represents the application on the software on your device. For example, your Internet Explorer, your email client, POP3 or SMTP, or your peer-to-peer client. So I will not go deep into the network. I just spoke about the 7 layers here to take the opportunity to explain how wireless networks was introduced. So if you can see here on the left, this 7-layer module represents the wired network. If you can see in layer 2 and 1 was standardized under 802.3, and this standard comes from IEEE, the Institute of Electrical and Electronic Engineering. It's the organization that makes so many standards for wired and wireless and other technologies. So in 1997, in 1991 they introduced the 802.11, and in 1997 they introduced the 802.11g. Sorry, in 1997 they introduced the 802.11, and in 1999 they introduced the 802.11g. So if you can see here on the left, 802.3 is in the wireless 802.11. All right, so the IEEE after that introduced so many Wi-Fi standards, and I will start with the 802.11b. It was in the early days of wireless, and the speed was about 11 megabit per second. Then they introduced the Wi-Fi 2. It's 802.11a, and the speed has increased to 54 megabit per second. And in 1999, the 11G came with again 54 megabit per second. However, this in 1999 it works on 2.4 frequency. Before the 54 was working only on 5 gigahertz frequency, and there was so many regulations on the 5 gigahertz frequency. Then in early 2010, we had the Wi-Fi 4, which is 802.11n. It can go up to 450 megabit per second. And in later phases, we had the 802.11ac, which is the Wi-Fi 5. It can go up to 6.9 gigabit per second. Tremendous increase in the speed, and I will explain why. Then we had recently, I mean up to date, today we have the 802.11ax. It can go up to 9.6 gigabit per second. And Wi-Fi 5E is the latest one. It's not yet approved in Oman. Oman will be TRA Oman has published public consultancy for this standard, and I believe it will be approved by the end of the year. All right, so If you can see here in my table, I have for each standard, I have three main elements. I have the frequency, the antenna, and the modulation. And I want you to think about wireless like this. We have a road, which represents the frequency, and we have a truck, which represents the antenna, and we have a load, which represents the data, the modulated data. And as you can see, if the antenna, when the antenna is better, it can take better load, and when the modulation is better, we can produce better data rate. So I will speak on each one of these three elements: the frequency, the antennas, and the modulation, to see what improvements have been done to the wireless network so far. All right, I will speak up first about the modulation. The modulation is the technique that changed the radio frequency into something that the computer understands, which is the 0, 1. We all know that computers only understand 0, 1. So in 2010, the 11N was using the 64 QAM modulation, which makes the modulation of 6 bits per sample, and we have 64 sample in this quadrilateral diagram. And we have in the 11AC 256 QAM, and in the 11AX we have 1028 QAM in the 11AX. And if we have better QAM, quadrilateral amplitude modulation, we have better throughput for the wireless. And how they do that? Each radio signal is like a sine wave. It has properties, and like for example, this sine wave has 3 main properties. It has more properties, but I will speak about only 3 main properties that are used to modulate the signal. We have the amplitude, which is the height of the wave, and we have the frequency, which is the number of waves on a given time. And we have the phase of the wave, which is the location of the wave in a given time. This is computed and then modulated into 0, 1s, so the computer can understand the data. I want you to think about modulation is like if you are going to throw a paper in the air, it won't go too far. However, if you put a stone inside the paper and throw it, you can reach your destination probably, and you can achieve more distance. This is the idea of modulation. Changing the radio spectrum into a pattern that can be understood by a computer. All right, so the modulation, as I said, it represents the load, the quantity of data that I will be computing to transmit over wireless. The second part is the radio spectrum. The radio spectrum is very big. I took this part of the radio spectrum. As you can see here, we are starting from very low frequency, which can be used for maritime. Low frequency can be used again for maritime navigations. And we have medium frequencies, which is used for AM radio, the regular radio that you hear every day. And we have the high frequency, which is used for the shortwave. And we have the very high frequency and the UHF. The very high frequency, as you know, it's used for TV and FM stations. Now in UHF, they use the Wi-Fi in the 2.4 frequency. And again, in super high frequency in SHF, they used the Wi-Fi in 5 gigahertz and 6 gigahertz frequencies. So from that spectrum, we had three main roads. As I said, the spectrum here represents the road of my network. So we had three main frequencies that can be used for wireless. As for now, as for today in Oman, we are using 2.4 and 5 gigahertz, 6 gigahertz yet to be approved. As I said, TRA has public consultation for that, and they did not allow it yet, but I believe it will be by the end of the year, one of the frequencies that you'll see in wireless networks. So 2.4 frequency is considered ISM frequency. ISM stands for industrial, scientific, and medical. It's a free frequency. You don't need to pay for it, but this frequency has only 13 channels. The 14 channel, it has 14 channels. The 14 is only used in Japan, but in the other part of the world we are using 1 all the way to 13. So we have 13 channels in this frequency, and it's used for many devices, like even your microwave oven at home, it uses 2.4, or sometimes your wireless phone can use 2.4 frequency. So many devices are using this frequency, including also Bluetooth devices and other radio home devices. So if you look at this frequency, we have only 13 channels, and they are overlapping with each other. So when they look at this frequency, they said, all right, channel 1 and channel 6 and channel 11 are not overlapping with each other, so we are going to use them for the wireless networks. And they started using them for the 802.11g, and the speed at that time was 54 megabit per second. Then they introduced the 5 gigahertz frequency, and as I said before, just to give you also a brief, frequencies, it's property of the government. I mean, it's owned by the government. Like each government, they own the frequencies, and they do the regulations for those frequencies to organize the usage of those frequencies and disallow interference between devices. So in Oman, TRA Oman, Telecommunication Authority, they are responsible for organizing network devices and radio spectrum. And if we want to use any frequency, we need to make sure that this frequency is allowed by TRA. In Oman, they allowed also 5 gigahertz frequency. Not all of it, of course. 5 gigahertz frequency has more channels, and the beauty about this frequency is that all the channels are not interfering with each other. So each channel is independent by itself, and it has ranges from 5.50 to 5.5250 and 5250 to 5350. This is allowed in Oman. 5350 to 5470 is not allowed even internationally. In Oman, it's not allowed, but even internationally, it's not allowed. It's used for other purposes. And from 5470 to 5725 is again allowed, and the 5725 to 5825 and 5925 is all allowed in Oman. And it's unlicensed frequency. You don't need to buy the frequency to use it. When I say unlicensed frequency, because some of the frequencies you need to pay to use that frequency, and fortunately for the Wi-Fi, all these frequencies are free. Oman, as I said, for the 6 gigahertz frequency, they are still doing public consultation for that, and I believe they will be approving the range from 5925 to 6425. And this is very good improvement for the wireless because you'll be having better road. Think about the frequency as a road. As I said, if you have a road of 1 LAN or 2 LANs or 3 LANs, so 6 gigahertz frequency will be having so many LANs, and it will be very wide, about 1.2 gigahertz of bandwidth that can be used on that frequency. All right. So I spoke about the modulation, which is the load. I spoke about the frequency, which is the road. Now I'll speak about the antenna, which is the truck that I will be putting my data in. All right, I will speak about two main types of antennas in wireless networks. Antennas, there are two types of antennas. Omnidirectional antenna that radiates signal on all directions, up, down, right, up, down, and right, left, south, north. And so the shape of the wireless network will be, the wireless coverage will be like a donut. This antenna is very good, and it's used in home networks and business enterprise networks. I mean, in offices, in classrooms, in corridors, in hospitals, in hotels, they use this antenna. Now, as you can see, this is the antenna shape, but it's not anymore like that. The antenna these days is integrated into the access point itself. So you don't see this unless you use external antenna. You want better coverage, or you want to cover more distance. So you can use external antenna, but most of the access points today, they have integrated antenna inside it. You don't see the antenna; it's inbuilt in the access point, and you will be getting the same result as this antenna for offices. But if you are doing outdoor, you can use the external antenna with higher gain, so you can get a better further coverage or better coverage. So the coverage of omnidirectional antenna is like a donut. If you are so close to the antenna, here in this spot in the middle, there is no coverage. So sometimes you are just under the access points, and you see that your coverage is not so good because you are inside the donut. You are not on the edge of the donut or in the middle of the donut. You are inside the donuts, and here the coverage will not be so good. The other type of antennas is a directional antenna. It's used in outdoor point-to-point connections and what we call a wireless bridge. And also, it's also used for coverage in stadiums, in theaters, and the directional antenna, it radiates in a single direction with a different angle. We have, like, if we want to go the signal to, if we want the signal to go for more distance, we can use like the 30-degree, or if we want to cover less area, we can shoot on 60-degree. And if we are, for example, in a stadium, we can use 120-degree antenna. And the degree and the dB values are specified in the antenna, and it's one of the antenna specifications. So when you buy an antenna, you can see how many dB it is, and what is the radiated angle for that antenna. All right. So in the early days in 11G, 802.11G, the antenna was a single antenna, and the speed was only 54 at those days, and they wanted to improve the wireless network into a better output, better data rates. So they thought about multiple input output antennas. Multiple input output antennas, MIMO, it was used in the GSM. So they borrowed this technology from GSM and they implemented in the wireless. And the idea behind that is, instead of having one antenna, I will have an array of antennas. It can be 2 antennas, 4 antennas, 8 antennas, and so on. And the more antennas I have, the better throughput I have. For example, here I have here 4x4 antennas, 4x4 antenna, which is which consists of 4 transmitters and 4 receivers. And when I have 4x4 antennas, I'll be having 4 data streams, or spatial streams, we call them. So instead of having a single antenna carrying one stream of data, I'll be having 4 antennas carrying 4 streams of data, and I'll be, of course, the result will be 4 times better. As you can see, as you saw in the first table, the speed in 11G was 54 megabit per second, but in 11N we could go up to 450 megabit per second. So a great improvement in the speed of the wireless network. So as a client, if I want to get this speed, I need to have 4x4 antenna as well to get the 450. But if I have only 2x2 antenna in my client device, for example, my computer or my phone, I'll be getting something around 300 megabit per second, which is also good. Now most of the mobile devices are 2x2. So most of the devices are 2x2, and some devices, some computers are 4x4, and there are some devices with 8x8 antennas. So the more antennas, the more throughput we have. All right. So the improvement on the MIMO antenna was introduced in 802.11 AC, the Wi-Fi 5, and this was introduced because to introduce one feature. If you have like 3 people connecting to one access point, if you stop the time and look at the connections, you will see that only one device is connected to the access point at a time. So the access point serves the users one at a time on different time interval. We don't feel this time. We don't feel, because it's fractions of seconds. We don't feel it, but the access point does not talk to each and every one together. It talks to one at a time in the MIMO antennas. However, in multi-user MIMO, this was changed. So the antenna now can speak to multiple users at the same time, and each with with independent data stream. For example, here, as you can see, the access point, this is single user MIMO, the regular MIMO. If I have a load, I need to put this load in this in the truck, and I need to deliver it to each and every one of these devices. While in multi-user MIMO, I'll be sending 3 trucks, and each truck to each user. So this will increase efficiency, increase throughput for the users. So and multi-user MIMO is very good in classrooms and lecture theaters and crowded areas and meeting rooms or conference rooms where we have so many users are connected. So the access point can talk to multiple users at the same time. All right. So back to my first table. I spoke about the road which is the frequency. I spoke about the truck, which is the antenna, and I spoke about the load, which is the modulation technique that will encode my data and make it change the wireless signal into 0, 0, 1s. Now, since I'm talking about antennas, I need to talk also about one concept. It's called SNR, signal to noise ratio. Signal to noise ratio, as you know, as I said, for example, in 2.4 frequency, if I have an access point working on 2.4, but I have other devices working on also on 2.4, could be on the same environment, and this will create a noise for me. So the noise comes from all the devices that are emitting a signal on the same frequency, and my signal should be powerful enough to be able to be received by the client device. Think about a teacher inside a classroom, and if everyone in the classroom is speaking, the voice of the teacher will not be heard very well, while if the others are silent, the teacher can be heard very well. And if they make a noise, the teacher then need to increase his voice to make his voice hearable by the or receivable by the students. So the better you are far away from the noise floor, the best is your signal quality. Let me give you an example. Sometimes we place an access point in a congested area, and there are so much noise from other devices, and in this case I need to place my access point in a location that will give me a better position in the frequency, and I need to increase my signal so it can be heard by the by my clients, and I need to give power to my signal to go further away from the noise floor. So I'll speak about SNR later in wireless planning. So when we are doing a wireless survey, we need to make sure that the noise floor is not too high, and to identify all the noise objects inside the room. All right, so let me talk about wireless modes. First of all, the types of access points. We have two main types of access points. We have the fat access point and the thin access point. And the difference between these two access points, a fat access point is an access point that has all the management and authentication, encryption, forwarding, mobility capability inside it. It's like the access point you buy it from the market for your home. It has everything. It has the software in it, and you configure it at home with that software. However, the thin access point has only the radio and the antennas. And this thin access point is managed by a centralized wireless controller, and the centralized wireless controller manages all the access points and both the policies, manage the mobility, and do the forwarding, the encryption, and the authentication for the wireless. And this thin access point is recommended for the enterprise networks like universities, hotels, hospitals, governments, where you have centralized management and you have better security in terms of authentication and encryption on the corporate network. All right. So SSID is the term that we hear every time. Can you tell me your SSID? Can you tell me your wireless network? A wireless network name is the SSID. And where did this come from? We call the station, the access point, and the station around it, we call them basic surface set, or PSS. And SSID is the surface set identification, and it can be up to 32 characters. When you write the name of your wireless network, it can go up to 32 characters, alphabet or numbers as well. And while the wireless access point broadcasts this SSID name in a form of beacons, each on time intervals, usually 100 milliseconds. Each 100 milliseconds, the access point will broadcast its name, and so you can see the wireless network name. Wireless SSID as well, it can be visible for the user, and it can be hidden. Sometimes if you don't want some others to see it, you can just hide it and teach your client to join it by entering its name manually into your client device. Extended SSID is the same as SSID. However, this is used in 10 access points where I have centralized management, and I create this SSID. We configure this SSID on the wireless controller, and it's broadcasted on the antennas and on the access points that are distributed over the building. All right. So Wi-Fi modes. We have 3 main Wi-Fi modes. We have the infrastructure mode, which is the mode where we have an access point and a client. This mode is called infrastructure mode. I have an access point and I have client or one more client or multiple clients connected to this access point. This mode is called infrastructure mode. And we have ad hoc mode. It's like the peer-to-peer connections. If I'm connecting 2 computers into a UTP cable, it's a peer-to-peer. Here, it's a peer-to-peer wireless network. We call it ad hoc network. I can make my laptop as an access point, and I can make other laptop connects to my laptop, and we can share data if I don't have an access point. The third mode of wireless network is the wireless bridge, where 2 access points can connect to each other and can link 2 buildings with each other. This can be point-to-point or point-to-multipoint. I can have here one building connected to building A connected to building B through one device in each building. However, I can have multiple buildings connecting to one building, and this is called point-to-multipoint. Right. Wireless security. All right, before speaking about wireless security, I'll speak about Wi-Fi Alliance. Wi-Fi Alliance is a group of companies and organizations that work to make standards for Wi-Fi. And if I think about it, it's like a FIFA for wireless companies. So they make the rules, they make the standards, and especially for those for the security. So when you buy a device, a wireless device, it's important to have it as Wi-Fi Alliance certified, because then your device complies to the specifications and to the improvements that the Wi-Fi Alliance is making for the wireless networks. All right. There are so many wireless security protocols that have been used before and are not used today, like the WIP, wired equivalent privacy, and the WPA1. They used them before, and they were cracked, so they are not used anymore. So Wi-Fi Alliance in 2004, they developed the Wi-Fi Protected Access 2, which is highly secure, and it uses advanced encryption system, and it uses a key size of 128 bit, and it uses PSK for personal authentication, and 802.1x for enterprise authentication. I will talk about 802.1x in later slides. However, for open networks, it was not there was no encryption, and for pairing devices, they used the WBS Wi-Fi protected setup. And this is those are the gaps in WPA2 that got covered in WPA3, introduced in 2018. Now, since 2018, WPA3 is used, and you need to make sure that your device is upgraded to support this protocol, and it is very high, and it uses, again, advanced encryption system, and with encryption keys 128 bits for personal and 192 for enterprise. However, it does not use the BSK, it uses SAE. For the user, it will be the same. Like you'll be prompted to enter your password, whether you are connected to WPA2 or WPA3. However, in the background, something else is happening if it's to WPA2, and if something else is happening is if you are connected to WPA3. And this technique was, I mean, the simultaneous authentication of equals. This technique was used in wireless mesh, so they brought it to wireless authentication using the Dragonfly handshaking protocol. I will not talk deeply about those protocols. However, what I want you to understand that the WPA3 uses more complicated and more complicated cryptography to encrypt your data and secure your authentication, because in the WPA2 was cracked in the in 2000, I believe in 2016. It was cracked by someone, and then they worked on this protocol to cover this area, and the BSK in WPA2 is subjected to dictionary attacks by hackers, where a hacker connects to steals some data from the access point and try to guess the access points, the passwords through a dictionary lookup. And this is not possible in WPA3. Again, in enterprise authentication, there is an improvement with the protected management frames, and the best improvement in WPA3 is in the open networks. Before you go to the coffee shop or airport or somewhere you have an open network, you connect to it, your data is not encrypted. And anyone steals data from the air, from the spectrum, can see what you are talking to the access point. You can see all your traffic going back and forth to the access point. However, in WPA3, they introduced the opportunistic wireless encryption, and this is used for open network. For you, it's still an open network. You'll not be prompted for a wireless. However, your data will be encrypted back and forth to the access point. And the improvement on the pairing, as you know, before we have the wireless Wi-Fi protected setup, where you have a button on the access point and button on a button on the device where it says WPS, and it connects to your device automatically. And it was a very big mistake for WPA to have this setup, because it's very vulnerable, and so many hacks were made through the WPS. So if you have a Wi-Fi device or Wi-Fi access point currently and you have WPS enabled, please disable it. So in WPA 3, they solved this problem with the QR code. Now, no need to press a button or configure a device to configure WPS on your network. You just need to scan a QR code that is specified for the device that you want to connect. And WPS and QR code is used for connecting printers, IoT devices, and other network devices that are not clients. All right, so I'll speak about the Wi-Fi authentications. As I said, we had the WPA3, which uses the simultaneous authentication of equals. When you put your password, you will be having SAE communication between you and the access point, where the device and the access point agree on a key, and then they can the authentication request, association request will be sent to the access point after agreeing on the key. The authentication request will be sent to the access point, and the access point responds, and then there will be four-way handshake, and this handshake will be encrypted until you get connected. You don't see all that, however, it's happening in the background to make sure that your authentication is secure and your data is encrypted. Other way of authenticating wireless devices is the MAC authentication. It's very weak authentication mechanism. However, if we combine it with other authentication technique like the WPA3, it could be useful for in some areas where I need to do MAC authentication. And the idea behind that is that we have a MAC address database placed in a database server or in the access point itself, and then when a station is connected, associating to the access point will look at the MAC address of that device and see if it's existed in the database, and accordingly it will allow this device or not allow it. All right, 802.1x authentication. This is very important authentication, especially for corporate networks, colleges, universities, hospitals, because this is a corporate kind of authentication where it combines two protocols, the 802.1x protocol and the extensible authentication protocol. The 802.1x is the IEEE protocol that responsible for opening or closing the port, opening or closing the surface. You can consider it as the gate, and the E is the messenger, is the extensible authentication protocol is for fetching the username and password for that user from a radio server. So to have this technique 802.1x authentication, we need a radius server. A radius server like Microsoft NPS or Aruba ClearPass or open radius server. There are so many radius servers out there in the market. And the radius server is a server that will be responsible for authenticating users on the wireless network. It can has its own database, or it can talk to other database. For example, you can have a radius server which can talk to Active Directory, and the users will be using their Active Directory credentials to authenticate to the network. So what will happen? The user here will try to join the network, and the authenticator here is the wireless controller, will speak to the radius server, and the radius server will respond that I need your username and password, and then after the client provides his username and password, the handshake will happen, and all this data will be encrypted. So there are two types of EAP. There's protected EAP and EAP TLS. And in protected EAP, we don't need a certificate on the client side. We just need a certificate on the server to make sure that we are connected to a legitimate server. And here the certificate is very important, because you need to make sure that you are connected to a legitimate server, and so you make sure that you are not connected to a hacking server. And the certificate is the best solution for that. So your computer will recognize that this server is connected, is holding a legitimate certificate, and you will be and then your Windows supplicant will allow you to connect to that server. In EAP TLS, it's more advanced, more secure, and it's recommended for high sensitive data. And it's in this scenario, we have the certificate on the server, but we need a certificate on the client as well. So for each client to connect to the network, he needs to install a certificate on his device to make sure that his device can do the communication to the authentication on the radius server. Captive portal authentication, we use it we see it in the airport sometimes, or in the hotels, where you connect to an open network. However, you are prompted with a page where you need to enter your username and password. It uses SSL encryption. However, this can only be used for guest networks and internet only surface network. You need to use it cautiously, and you cannot use it for corporate network. Maybe yes, for your guests, you can create an open network and make an authentication portal page for them to authenticate on that page, where and in the background you'll be having a server to create their username and passwords, or even in the front desk, or the secretary could have access to create username and passwords for those guest users, instead of having like one password shared to all guests that are coming to your facility. All right. Wireless planning. All right, so when I want to plan a wireless network, I need to first understand the characteristics and properties of the area that that I'm working in. So what I need to cover: indoor area, outdoor area. So what's the building type? It's an offices, it's a school, it's residents, and what are the walls? Are they concrete, blocks, gypsums, and or glass. Also the windows, I need to look at the windows. Are they protected by metal, or it's only glass? Are they transparent or dimmed? The doors, are they wood, metal? So all these elements will make me understand the type of access point that I need to place in terms of antenna, in terms of access point location, in terms of the power of transmission that I need to apply on the frequency. Again, the ceiling height. Is the ceiling very high? For example, if I have a classroom, the height of the ceiling could be 3 meters, so I can place the access point on the ceiling. But in an auditorium, the ceiling is very high. It could be 7 meters height. So it's not recommended to place the access point on the ceiling. In this case, it's better to bring it a little bit lower, up to 3 meters or 4 meters minimum, so I can achieve a better SNR, signal to noise ratio. In 7 meters, the signal can still reach, but I need to actually have better SNR. So I place my access point in a better position in the frequency in the room. And I need also to identify any attenuation factors like AC, microwave, other electromagnetic radiators like AC. And maybe lights, maybe some generators inside the room. I need to identify all that. So and also GSM antennas as well. I need to identify all the attenuation factors and place my access point accordingly. And I also need to understand the number of to take an idea about the number of users. For example, if I have a classroom with 30 students, and these 30 students will be connected with 30 devices. Yes, one access point in this case will be enough to cover them. However, MIMO access point will not be a good choice for me. Multi-user MIMO access point will be the best choice for me. And 2x2 will not be a good choice for me. 4x4 antenna will be a better choice for me. So this is how we size the network. For example, in a congested area, I need to have better antenna. And more number of antennas, like 4x4 or 8x8, if I can, in high congested areas. And the type of antenna, whether it's a directional or omnidirectional antenna. I also need to understand the usage of the wireless. Is it used for internet, or it's used for accessing learning resources or big file transfer? So this will also give me an idea on the type of access point. Sometimes in some areas I can place 2 access points in the same classroom just because of the number of users. Let's say if I have 60 users in one classroom, though the access point can talk to all of them. However, if I want to achieve better experience for the users, I can place 2 access points that can serve all the 60 altogether. Though the coverage will be done by 1 access point in the classroom, but placing 2 access points will give me better throughput for the users, and will give me also redundancy on the access point level. It's also good to look at the site plan of the building. and take the measurements and understand the characteristics of the building from the site plan, and maybe use some wireless planning tool like Aruba Airwave or Ikahow, or there are so many tools out there that you can use. I believe there are some tools also on the internet that can be free. You can download it for free, and you just need to upload your drawing and then place the access point and look at the expected coverage that you'll be having after placing the access point on the map. All right, I believe this is my final slide. Here I want to give some tips about the wireless before taking your questions. So always make sure that your Wi-Fi device is approved by TRA. Here in Oman, in each country, as I said, Telecommunication Regulatory Authority is responsible for communication devices and for the spectrum. So why it's TRA is important? Because TRA is important because when a device is approved by TRA does not only look at the allowance of spectrum. It looks at the safety of the device, the amount of radiation that is coming from the device is safe for human or not, the environment safety of the device as well, and they require from the manufacturers so many test reports to prove that this device is safe and is working according to the international standards of safety of wireless networks for communication devices. Sorry. So it's always better to buy an TRA approved device, and if the device is not approved by TRA, it means that this device is illegally entered Oman, because TRA will not allow any device in Oman unless it's approved by the TRA. So if you are going for any device, whether it's wired or wireless, you need to ask for the TRA approval for that device to make sure that this device has been checked by TRA and approved by TRA. Also, make sure that your Wi-Fi device is Wi-Fi Alliance certified, because some companies are not part of the Wi-Fi Alliance, and that means that you'll not have the benefit of all the protocols and the standards that have been made by the wireless companies. So make sure that your Wi-Fi device is Wi-Fi Alliance certified, and always use the latest security protocol. For example, here we have the WPA3. It's the latest one, and it's now time to upgrade your wireless device software or firmware to be able to use the WPA3 security. Always upgrade your firmware. Like each 6 month time, try to check for a newer version of the firmware of your device. Always change your default username and password. Don't keep them as the same. Disable WPS. This is very important. Disable Wi-Fi protected setup. Disable it, because this is very vulnerable for attacking. Use strong passwords and change it frequently. Do not ever share corporate access credential. This is very risky. I mean, like your username and password in the learning system or in the college. Don't ever share it with anyone, because this will put you under responsibility for any bad act on using your username and password. Do not join unknown wireless networks. This is very important because one of the hacking procedures is to make a fancy wireless network that has internet, and you join it. It's open network, and then your device will be hacked from that network. Understand your needs before planning, before buying a Wi-Fi device. You need to plan before buying a Wi-Fi device or a Wi-Fi or a Wi-Fi network in general. You need to plan for that. All right, so let's say you have an office and a meeting room and a classroom, and you want to cover that. So you need to understand the characteristics of each location and the needs of each location, and accordingly buy the device that fits your needs. And the same thing for your home. If you want to buy for your home, you need to understand your needs and the characteristics of your home, and after that you buy the Wi-Fi device. Always use 5 gigahertz if it's supported by your device. I mean, most of the devices now are supporting 5 gigahertz. And why I'm saying 5 gigahertz? Because it's a better highway, it's a better frequency, and there is no overlapping on the channel. There less interference, and of course better throughput. Always use radio server 802.1x for enterprise network access. Do not make enterprise access under username and under password only. This is again very risky. Just use the 802.1x for the corporate and enterprise networks. For guests, you need to create a limited access network that has only internet and with only limited internet as well, and can be controlled with the captive portal authentication. The 14th tip is avoid using wireless repeaters. I did not speak about them in the seminar, in the session, but however, wireless repeaters, we see them in the market where we have an access point and you bring a repeater, you plug it on the wall, and do not use it at work. Maybe at home, yes, could be. You can use wireless repeaters, but at work, for businesses, no, don't ever use it, because wireless repeater actually takes the signal and then repeat it to the client, and this will not give you a good experience. You'll find so much disconnection, and so much of the data will be corrupted during this process. So the bandwidth will be affected, and the experience of your connection to the wireless repeater will not be so good. Place your antenna or your access point away from interference sources like GSM antennas, access points, other access points, ACs, microwave ovens, or any other electromagnetic source that you think that it will create a noise on the signal. Those are the 14 tips. I believe that was my presentation, and that was my last slide. I hope it was informative, and I'll go to the Q&A session right now.
Thank you, Mr. Youssef, for a very interesting session. Now the floor is open for questions. Yes, please. Please unmute yourselves or raise hand if there is any question. It seems the session was very informative and it was very clear. I guess there is no question. No hand is raised.
السلام عليكم.
Yes.
عليكم السلام.
Dr. Esma.
أهلين أخي يوسف. Thank you very much for a very fruitful presentation and knowledgeable presentation.
Thank you, Doctor, for your invitation. It's a great honor for me to be with you here on this session today.
It's an honor to have you as one of our speakers. Thank you very much for joining us.
Thank you so much.
I did not really, to be honest, attend the full session. I managed to attend the last part of the session, and I was wondering if you can slightly talk maybe about the security of wireless, as it is one of the challenges usually in organizations. Thank you very much.
Yeah, sure. As I said, for organizations, for enterprise networks, we need to make sure that our wireless network is secured and our backend as well is secured. So we need to secure the wireless first, and then we need to have a security at the back end. The security in the wireless will be done through the latest mechanism of authentication to the wireless in WPA3 with 802.1x. This is the one of the most used and most powerful authentication mechanisms so far, where the users can only get access to the network if they provide their username and password, or if they provide their certificate if we are using EPTLS. This will save time as well. For example, in a college where each student and each college member and staff and teacher has his own username and password on the domain, then you don't need to create username for each and every one. They already have it. Then it's just a matter of integrating your radio server with the Active Directory, where the users can use their Active Directory credentials to join. And here for the 802.1x, we can have two type of authentication. I can combine the machine and the username. Let's say if it's a computer joined domain and the user is valid, I can give him different rule, and if he's only providing a username and password, Active Directory credentials, and he's using his own device, I can put him in a different location, and that depends on the services that I want to give to the college or to the location that I want to cover. For example, if for the staff, most of the staff will be having computer joined domains, so I can only allow those computer joined domains to join this network. This is very, very secure. For computers that are not part of my domain, for example, the students, I can take them to a different level. I can authenticate them with the username and password, again through the radio server, but maybe I can place them in internet only session, or internet with the some access to the resources in the college portal or university portal. If I want also to apply health check on the device, again, some radio servers are integrated with they have the network access control capability, where the device will be, the radio server will enforce health check on the device before it joins the network, where it checks if it has an antivirus, if it has updated Windows, and if it has the security patches that are required to join the network. Of course, for critical networks, we need to apply the maximum security as maximum as possible. We need to build our fence as high as we could. For networks that are serving only internet, we can accept to we accept to give them open network with the captive portal authentication, where they need to register their username and password. They either can use their Active Directory and credentials for accessing the guest network, or they can get guest access from the admin or from the IT, guest username and password. And here the access will be only to limited internet. So the more critical the network, the higher my fence should be. And the less critical the network, I can go with the shorter fence, and I can go with the this type of security to just make things go faster for the guest users, and not complicate authenticating the users on the network. However, with the integration of Active Directory, I mean for the corporate network itself, with the integration of the Active Directory, it's now even simpler. Before it was like a little bit complicated. We need to create username and password for each and every one. Now it's very simple. I mean, the user can just use his own credential, and he can join the network, and he needs to enter them only once, and he can save them in his computer, and he will be given the access to the network. This is the part of the security on the wireless network. And now on the back end, on the core network, we need to work on the firewall, on the policies. We need to create policies for the departments, like for example LRC maybe or IT are having different rules from finance. Finance are having different rules from admin. So I need to work on I need to make sure that each one is accessing the right data and is placed on the right role, and I need to have a little bit of control on the core. And on the core, I can use either the integrated firewall inside the controller, or I can use a separate firewall to create policies and roles for the multiple networks that I have. And it's always nice to have multiple VLANs to segregate all the users on my network. So this is about the corporate security. And again, I need to just emphasize the idea about the usage of WPA3, because as I told you, WPA2 was cracked, and the Wi-Fi Alliance has introduced the WPA3. So make sure that your device is WPA3 capable. If you upgrade your firmware, if currently your Wi-Fi device is not upgraded to the latest firmware, you need to upgrade it to make sure that WPA3 is enabled. And after upgrading your firmware, WPA3 will not be enabled automatically. You need to go and configure it to make sure that you are no longer using the old technology, or using the new authentication mechanism, the Wi-Fi protected access 3. So this is one important part of wireless security. And also I need to ensure again, please disable WPS Wi-Fi protected setup. It's very dangerous. If your device is support, whether it's at home or in the work, always disable Wi-Fi protected setup. Do not use it.
Thank you very much for a very detailed explanation. We will be in touch, inshallah, later for future collaborations, bidnillah. Thank you very much, Yusuf.
Inshallah, thank you so much, and thank you everyone for attending. And I'll be sharing those slides with by email. So if you want to review what have been spoken on this presentation, you can go back to it anytime. And if you have questions, or you found questions in the future about wireless networks or any other subject, please feel free to email it to me, and I'll be more than happy to reply.
Thank you very much. I'll leave the floor to Mahfouza. Thank you.
Thank you so much.
Thanks a lot, and thank you, Dr. Asma, for joining us. At the end of this talk, join me to thank our guest speaker for his informative talk about wireless networks, and would like to remind you all that today's talk recording will be available in ETC Talk webpage, as well as the presentation when Mr. Yusuf shares it with us. Thank you one more time, Mr. Yusuf. Thanks a lot.
Thank you so much. Thank you so much. Stay safe. Have a good day.
Yeah, stay safe, all of you.
Thank you so much.